Good morning, student. Today we are going to learn about pulse amplitude modulation and demodulation. After the completion of today's session, you are able to define pulse modulation, classify pulse modulation, explain the generation of pulse amplitude modulated signal, and describe the demodulation process of pulse amplitude modulated signal. Before going to the topic directly, first we discuss about the pulse modulation. So in pulse modulation methods, the carrier is no longer a continuous signal but consists of a pulse train that is divided into two types: pulse amplitude modulation and pulse time modulation. In pulse amplitude modulation, the amplitude of the pulses of the carrier is changes according to the modulating signal, whereas in pulse time modulation, the timing of the pulses of the carrier changes according to the modulating signal. So, again the pulse time modulation divided into two types, that is pulse width modulation or pulse duration modulation and pulse position modulation. In pulse width modulation, the width of the pulses of the carrier signal is varied in accordance with the modulating signal, whereas in pulse position modulation, the position of pulses of the carrier pulse train is changes according to the modulating signal. Here you can see this one is the modulating signal, this one is the pulse amplitude modulated signal. Here amplitude of the carrier pulses changes according to the modulating signal. Here you can see the amplitude of the pulses are not same, they are varying according to the modulating signal. Then this one is the pulse width modulation. Pulse width means width of the pulses changes. So here you can observe that the width of each pulse are not same, they are varying. Means here the width is more than this pulse. Like this you can observe all the pulses. Then pulse position modulation. If you consider this dotted line as the center line, then you can observe they are not in same position with respect to these center lines, means their position are changes. Okay, so next we discuss about pulse amplitude modulation. Pulse amplitude modulation. In pulse amplitude modulation, the amplitude of the pulses of carrier signal changes according to the modulating signal. So the pulses in a pulse amplitude modulated signal may be of flat top type or natural type. Out of this pulse amplitude modulation methods, the flat top is most popular and is widely used. The reason for using flat top is that during the transmission, the noise interferes with the top of the transmitted pulses, and this noise can be easily removed if the top is flat. Okay. So first we discuss about the generation of pulse amplitude modulated signal. So a sample and hold circuit is used to produce flat top sampled pulse amplitude modulated signal. So the sample and hold circuit consists of two FET switches, means these two. Okay. Then a capacitor means 3 components are present, 2 FETs and 1 capacitor. The sampling switch is closed for a short duration by a short pulse applied to the gate G1. So when we apply a pulse, this sampling switch is closed. Okay. During this period, the capacitor is quickly charged up to a voltage equal to the instantaneous sample value of the incoming signal. So the input signal is applied here and a pulse signal is applied here. When a pulse signal is applied, for that duration only the sampling switch is closed. So in this waveform you can see this one is the modulating signal, and when the pulse is applied to the sampling switch, at that time the capacitor starts to charge. So here it starts to charge up to the maximum value at that instant. So at this instant the maximum value in the modulating signal is this point. Okay. So it charges to the maximum value of the modulating signal. Then the sampling switch is open, means when the pulse ends, then the open the sampling switch, means it is not in a activated condition. For that duration the capacitor C holds the charge, means the capacitor C charge up to this value, and when the sampling switch is open it holds this value up to what time? Until the discharge switch is closed. Okay. So when another pulse is applied to this G1, at that time the discharge switch is closed and this pulse means the charge hold by this capacitor again discharge to 0 point. So in this way the pulse is complete. Next again when next pulse is applied to gate G1, again the capacitor is charged up to the maximum value of the modulating signal. Then after some time this sampling switch is opened, and the capacitor C holds the charge until the discharge switch is closed. When the discharge switch is closed, it's again discharged to 0. This process is repeats again and again, and we get our flat top samples. Okay. Hence the output of the sample and hold circuit consists of a sequence of flat top samples. So this one is the theory. Next is the demodulation of pulse amplitude modulated signal. So demodulation is the reverse process of modulation, in which the modulating signal is recovered back from a modulated signal. For pulse amplitude modulated signals, the demodulation is done using a holding circuit. So this one is the block diagram. This block diagram consists of two blocks, that is a holding circuit and a low pass filter. So the received pulse amplitude modulated signal is allowed to pass through a holding circuit and a low pass filter. In the holding circuit, this one is the internal diagram of holding circuit. So in the holding circuit, the switch S is closed, this one the switch, after the arrival of a pulse, and it is opened at the end of the pulse, means if this one is the pulse, then the switch is closed for this duration. After the end of the pulse, the switch is again opened. Within this duration, the capacitor, means this one, the capacitor charged to the pulse amplitude value, means if this one is the pulse, the capacitor charged to the maximum value, means this one is the amplitude, maximum amplitude of the pulse. So the capacitor is charged to the pulse amplitude value and it holds this value during the interval between the two pulses, means here is the one pulse, then another pulse. So the interval between these pulse, that duration the capacitor hold the charge. So here you can see first pulse is this. So capacitor charge up to its maximum value, then after this point the switch S is opened. Capacitor then also hold that up to this, hold that charge, the interval between the two pulses. Okay, then again next pulse comes and the switch S is closed, means the next pulse is this one. So the difference value is decrease, means again it charged to that pulse's maximum amplitude and hold that value. Again the value decreases and it charged to the peak value of the next pulse and it holds the charge until the next pulse will come. This process repeats again and again. So this structure, it comes like this. So here it is given. Okay, so but in actual we never get a staircase signal. It looks like a staircase. So to smoothen this signal we use a low pass filter. This low pass filter is used to smoothen the output of the holding circuit. So after the operation of or function of holding circuit completes, the output of the holding circuit is smoothened in low pass filter. So this is all about pulse amplitude modulation and demodulation process. Thank you.